Hello guys, how are you? Welcome to my channel, the Stackless Engineer, and in this video I am going to solve the Leetcode POTD, that is problem of the day for 4th February 2024. Today's problem is minimum window substring, and so we are going to solve it. So let us first start with the description of the problem. What the problem basically asks us to do. Here it is. So I have solved the problem and I've solved it very optimally so that like runtime is only 3 milliseconds. It beats all like 98.54% of C++ users. I've solved it using sliding window. So let's first start with the description of the problem. So what the problem asks us to do. In the problem, we are given two strings. One is S. We can see also we have given string S. We have also given string T. Now, what we have to find? We have to find the substring of minimum length from S such that the condition is every character in T must be present in our substring. If there are multiple A's or B or any character in T, then at least that many character must also be present in our substring. Suppose if there are 2A, then at least 2A must be present in our substring also, and the length of the substring must be minimum. It also states that the answer would be unique, so there would be only one answer. And if we do not find any answer, we have to just return an empty string. Here you can see that our string has only one character A, and our target T is AA. So in no way possible we can find a substring such that it contains at least 2A. So we return empty string. Okay, just let me check if it is everything is fine. Yes. So let's see how we solve the problem. I basically solve the problem using a sliding window approach. So it's compare of n approach. The central idea behind the intuition or the approach in my sliding window is to match, like I do sliding window in this as to match which substring basically satisfies our condition. How we do it? We do it using a concept of like unique characters. So let me first explain you this and then we will move on to the solution in our slides. First we find the unique characters in T, and we also take the count of each characters in T. Here is only A, B and C. So unique characters is only 3 and count of unique characters is 3. In our sliding window, we see like how many matches we have got. The character A would be matched only and only when the count of character in T, let me again say it, the count of character in S is more than the count of character in T, more or equal. In that case, we say that we have got one match for corresponding to character A. In this way, if for all the characters, unique characters in our T, we find matches, that is number of matches equals to number of unique characters in T, we say that our window is like valid. We have found a valid substring. So using this concept, we run our sliding window and we find the minimum length substring which satisfies our criteria, and hence we return it. So let's move on to a slide. See. So these are just we have initialized n and m corresponding to the size of S and T. Count of T and count of S. Why 123? The character small z, the ASCII value of it is 122. So 2, because our input string contains both small as well as capital letter. So to encompass all of them, we have chosen 123. Count of T is corresponding to string T, and count of S corresponding to our string S, our main string, and that is our target string. What is count of, say, count T of A means? It means how many characters A is present in our string T. Same for S. So here we will first populate our count of T for string count for string t. And what is C count of t? C count of t basically means only the unique characters, number of unique characters in our target string t, or characters in our count t. Here in our for loop we populated the count of t, which is basically keeping track of the count of characters. You can easily understand this. And also we populate the unique characters count, that is C count t. Okay, let's go ahead. And this is our which basically tracks the matches. If matches equals to C count of t, that is number of unique characters, means our window is valid. So we will use it. Let's first this ing. This basically this is basically our window of it. In our sliding window, we have window I to j. That is our window. Here we are finding the first window. That is, we are finding the valid value of j. Let's see how it is finding. First, we take the character, basically convert it to int. That's not needed, but for clarity, we have done it. And here for count of string s, we increase it. And if our count of string s equals to the count in our target string t, means that's a match. That is, if we have found 3 A's and our target string also has 3A, then that's a match. So A is matched, and here this character is matched, and we increases C matches is increased. That is, characters matched is increased. And if characters match equals to number of unique characters, that is C count t, number of unique characters in t, it means our window got valid. It is a valid window, and this corresponding substring is also valid. In that case, we break. So we found our first j, the first valid window. If j double equals to n, means we have not found any valid substring. So we return empty string. There's no answer is there. Here I and j are inclusive. What does it mean? That our window from I to j, the corresponding substring includes both I and j characters. Here we are just taking the answer like I to j. We are assuming this would be our answer. In the further iteration of sliding window, our target is to minimize the length of it. So this is our main substring for loop. Sorry, sliding windows for loop. This is the main for loop. Now here in this for loop, we are just going to remove the character ith from the sliding window, and then we'll continually we will be increasing j such that the characters matched would be again equal to the number of unique characters. Like upon removing the character I, if our character matches reduces, so what is the minimum index of j such that our sliding window is again valid. That is what we are going to do. Let's see. So this is our I character. We have removed it from the count of s, and now if the if it got below, if it got reduced by the count of that character in our t string, then we reduce the C matches. Now we'll ask why plus 1 and double equals to, why not just less than equals to? That is because the C matches only the C matches is only for unique characters. If we say less than, then redundant values would be there because we are only taking unique characters here. So this is again the same as we have done before. We are here increasing our j value such that to find the valid window or substring. This terminates when our characters match equals to number of unique characters in t. And once since terminate, we have our valid I and j. Here I is exclusive because he just deleted I, but j is inclusive. And for that reason, if you found a valid, the number of characters match equals to number of unique characters in t, and our this we have found a valid. We have found a valid window, and if this length which is smaller than our current answer, in that case, we replace our answer with our current window. Now since here I is exclusive, so we don't need to add 1. but there in our answer ing are inclusive, so we have to add one to get the length of it. So yeah, congratulations, our solution is done. Now we just return the substring corresponding to our indexes. That's it. So thank you very much for watching this video. Hope you have understood the problem. I will try to make better video as much as possible. Thank you very much for watching the video, and hope we'll see you again. Thank you.